sometimes that bearing area needs to be larger. Okay, now we're going to actually get to the tricky part of this session, this code section. The attachment must also resist horizontal displacement. So that's really all we know. The goal is to keep the post under the beam, or keep the beam on top of the post. But we don't know what is trying to knock it out. We don't know what that load is or how much needs to be resisted. Is it the sway on the deck that's translating to the post? Is that what we're trying to resist? Well, we talked about that in course 2, and we know that we don't know what that load is. So that doesn't help us at all. Is it a force in this direction due to the torsional moment of the beam? Right? We learned about that with the joist, that's that effect of them wanting to roll over. Well, that could be a part of it, but that is a much more complicated discussion with beams, and it's nothing the code alludes us to. So what about this? Is somebody leaning on the post? Is that the force? I mean, yeah, of course, right? It should be strong enough for that, but I didn't get that from the code. I just got that from what is the concern in deck construction. Well, for guards, we have to resist 200 pounds laterally. So should that be it? Should that be the lateral load that we're trying to resist? I mean, honestly, I'm asking here. I'm reaching out because you know what? The code doesn't give us this information. And if we ask these two guys, we're probably going to get some very, very different answers to what will resist lateral displacement and what the target even is. All right, so if we read further in this section, though, the code does provide some, this ought to be good enough, kind of provisions that can help out with it. It points us to 2 figures with some connection details. Now, why do I say that these are, well, that ought to be good enough provisions? Is because we don't know what forces these details are even working against. So anyway, let's go over the first one. It's a generic installation to depict an approved post cap. And approved is defined as acceptable to the building official. So how would a building official find this acceptable? Well, in the previous session about joists, we looked at the load capacities, right? Because the hanger has a pretty big responsibility of transferring those very well-known live or snow loads over to the ledger or beam. But for beams, those known vertical loads are expected to be bearing directly on a post. Or maybe you could create a design where they bear in a hanger onto the post. And we go about that hanger route. Remember, just be sure to follow installation instructions, load ratings. That idea is beyond this course, but you should have enough information if you wanted to pursue it. So when it comes to resisting horizontal displacement, how do you go about approving the many, many common post caps on the market, like this AC6 I've seen a million times? So let's go to the load table and let's look at the notes for the AC6 top cap that I just showed you. And again, this is just an example from a manufacturer I chose. Now, the AC6 is included here with a few other 2-part type of top cap connectors. And the table notes that the loads only apply, the load capacities in this table only apply when these are installed in pairs. And then you've got lots of information here, and it's the stuff you should read for whatever products you choose to use, or if you're inspecting or designing one of these. But what I just want to use is this, to talk about the loads that are tested for. And look at this, we find it. They've tested these for a lateral load capacity. That is awesome. I just don't know what it means, because I don't know what lateral loads we're resisting. Now, this ties back to course 2 even more about lateral bracing of the deck. And why do I say this? Is because if you read the general notes for all post caps from this example manufacturer, you're going to find this. It says allowable lateral loads for post caps can only be achieved if one of the members, the post or beam, is supported laterally by other means. So what it means is if you have a wiggly post and a wiggly beam and you connect them together, they're just going to wiggle together. So Unless this post is somehow braced on its own at this location, then the loading on the beam in this direction is basically saying it doesn't even apply. But that's okay, we don't know what it is. All right, so let's go back and look at some more of these specific product notes. We see that this one particular post cap is only tested for directions parallel to the beam. But we just canceled out that direction, at least when it comes to sway of the deck. So this is all saying that this load capacity for that particular hanger doesn't apply to loads in this direction. And hey, that AC6 is not installed in pairs. Is that a problem? So what does that mean? But what does that mean with this LPC post cap, right? That can't take those lateral loads perpendicular. Well, that's in the Simpson deck guide. So are we to say that this particular post cap is not acceptable to resist horizontal displacement because the load capacities don't tell us that? Well, if that's what you think, it is not because you heard me say it, okay? And just in the same way, I've got nothing to say about this concealed beam tie thing here that I've never seen until creating this slide. My question is simply the same as Simpson posts here: resisting horizontal and lateral displacement. So remember, those two don't look anything like this in the picture in the code. And again, that's not the point. This is just illustrative. So let's go back again to the Simpson table, because there's still more here to dig up. Notice here that it says these post caps are not designed to transfer tension loads between spliced members. And actually, you find this note in the general notes for all post caps. So back to the IRC figure again. Now, this note here about splices has nothing to do with the connection. It's just a reminder that you have to put all beam splices over a post or bearing area. And I got to be honest, I can't say I've seen many builders splice a 3-ply beam like this over a post. But we should know that the post caps are not going to resist tension for this exact beam splice pictured here. And I guess that doesn't matter because we don't know what that tension load is anyway. So with that setup, let's go ahead now and let's look at this next illustrative figure, this next figure here in the code. And now this one states this minimum 5.5 inches. And again, remember, this is not about bearing area for each end of the beam. This is all about connections. That one is. And so what that part is about is it's about these edge distance requirements in this figure for a notched post to beam connection. Now first we got to do a little clerical fix up, okay? Right here where it says minimum 1/2 inch, that is just a typo in the code. It should read 2.5 inches. That's what it reads in the 2018 IRC. But you'll probably find out soon that I'm not holding that tight to that number anyway. Now if we look here, it specifies 2 1/2-inch diameter bolts, and then it says or approved, right? We know what that means. Approved equivalent connector. And in any normal sense of reading code, we would assume that to be equivalent to 2 1/2-inch bolts. And that's probably what most people are going to think when they read that. I just want to point out the irony that 2 1/2-inch bolts aren't equivalent to anything that we know of that we're trying to do. They're probably good enough kind of code provisions. So just as we looked at these post cap methods a minute ago from Simpson, well, if we scroll down this picture, they also provide some other cool alternative connections using structural screws. Now, do we look at these and scrutinize them to be equal to 1/2-inch bolts? Or should they be equal to that wide variety of load capacities and no load capacities we found in the tested post caps? Or what about this alternative through bolt system from Fasten Master? Now they state in their literature that they resist uplift and lateral displacement equal to traditional bolted connections. Well, is that okay? Is that enough? Or does it have to be specifically equal to 1/2-inch bolts? Well, you didn't hear me say that, because there's still more to talk about here. And in this figure down here, we get some very specific edge distance requirements. And you can look over and pore over these on your own if you'd like. All of these edge distance requirements come from the NDS, and this is what provides the standards for wood engineering. So these distance limitations are for when you need to determine a guaranteed load resistance because you probably have a load that you know of. So, like the tension load across this beam splice right here, well, those half-inch bolts would be able, those edge distances would design to actually say, yes, we can resist that tension if we knew what it was. All right, so there's still one more detail, and this is in the code section, not in the figure. And here it says that there must be a washer under the head and nut of the bolt. Well, okay, pretty specific. And what this means, and it was kind of intended to mean, was to prohibit the use of carriage bolts in this beam to post notched post connection. Now, why? It's because technically carriage bolts are not a wood to wood fastener. They aren't recognized by the NDS, and you can't get any engineered load resistance for that type of connection. So even though we don't know what we're resisting, if it's not recognized in the NDS, it makes it really hard to be recognized when you're developing IRC code. So again, though, the only goal we know is still this. All right, now there's one last portion of the code to go over, and it's going to kick us back to the manufactured post connections. Here it states that manufactured post to beam connections shall be sized for the post and beam size. Now, this is probably the most popular post cap design on the market, and different manufacturers have similar designs. Well, let's go look at the load table for this particular one. We can see that there's dimensions for what fits, right? What this was designed for. And for a 6x6 post, the width that is provided for the beam is 5.5 inches. And for a 4x4 post, the beam width portion is basically about 3.5 inches. And this brings some things to mind. It's really common to see 4x4 post caps like this used on a 3-inch wide beam, just a 2-ply beam. And it's kind of bent over a little bit to fit. Well, will this still resist horizontal displacement, or is it a fail? What about it? Would that change? I guess it would, right? If the beam plies happen to be separated by a 1/2 inch. Now, is that suddenly, if that was the same picture before, would that suddenly change everything about resisting lateral displacement of an unknown load? Now, for more fun and confusion on this, take a look at this illustrative figure in the code, and it looks to me like a 3-ply beam without spacers, which would only be about 4.5 inches wide, not the 5.5 inches that we just saw one example of that post cap is designed for. So what if the builder, again, uses those 1/2 inch fillers, right? Well, now they're out to the full depth. But wait a minute, that's a different post cap. That's the AC6. And when you look at the dimensions for this post cap, the beam dimensions aren't actually so defined. So is it okay then for that to bend a little bit over if we don't find it in the load capacities? Okay, guys, I think you get the point. And so my final suggestion, understanding everything I've talked about and how loose this kind of whole thing is, my suggestion is this: look at both of these details reasonably. And these details, you don't have to look at them so significantly and so precisely. Just like the post cap load capacities and notes about lateral loads, you might not have to scrutinize so precisely, because the goal is to resist horizontal displacement of reasonable loads that are quite undefined. Now, a deck like this, okay, that's a whole nother level of lateral displacement. We're talking about vertical posts this whole time. I'm expecting that engineer for this one, certainly.